Hello and welcome to the new style Edexcel GCSEs. These are the ones that go from grades 9 through to grade 1. This is paper 1MA1/1H. It's the first paper in the higher tier. It's a non-calculator paper and we're picking up in question 18. Solid A and solid B are mathematically similar. That means if the ratios of the lengths of one shape, the other shape will have to have the same ratios of lengths. The ratio of the surface area of solid A to the surface area of solid B is 4 to 9. The volume of solid B is 405 centimeters cubed. Show that the volume of solid A is 120 centimeters cubed. Okay, so if the ratio of the surface area of solid A to the surface area of solid B is 4 to 9 and the shapes are mathematically similar, then that means that the ratio of the lengths is going to be the square root of 4 to the square root of 9. Okay, so let's try and explain why that is. Let's say that I've got two squares, a littler one and a big one. And let's say the bigger one is twice as big as the smaller one. So let's say that this one, actually it's not squares, let's pretend they're rectangles, and this one side is 2 and the other one's by 3, and they're mathematically similar. So if this length is twice as big, then this length has to be twice as big as this length, so that becomes 3 times 2, which is 6. So the question is the area now twice as big or 4 times as big? Well, if we've multiplied this length by 2 and this length by 2, then we've multiplied the area by 2 times 2, or 2 squared. So it should be 4 times as big. But let's check. 2 times 3 is 6. 4 times 6 is 24. And 24 is 4 times bigger than 6. Let's try and expand this now into the third dimension, and we'll look at a cube and we'll worry about the volumes. So let's say that this is a cube, or not a cube, a cuboid. And let's say that it's 2 times 3 times 4. And that this cuboid is twice as big as this cuboid. So again, if they're mathematically similar, just like with the square or the rectangle, if this length is twice as big, then this length is twice as big. If this length is twice as big, then this length is twice as big. And if this length is twice as big, then this length is twice as big. So what we've done, we haven't scaled it up by a factor of 2. Or we've scaled up the lengths by a factor of 2. We've scaled up the area by a factor of 2 times 2, or 2 squared. And we've scaled up the volume by a factor of 2 times 2 times 2, which is 2 cubed. Okay, I don't think we actually need to go through the calculations because that's just going to distract us from the actual question. But I hope that's made it clear why the ratio of the lengths is going to be the square root of 4 to the square root of 9. So the ratio of the lengths is the square root of 4 to the square root of 9. Which is equal to 2 to 3. So therefore, the ratio of the volume is 2 cubed to 3 cubed, which is equal to 8 to 27. Because we know our cube numbers. If not, 2 times 2 is 4, 4 times 2 is 8, and 3 times 3 is 9, and 9 times 3 is 27. Okay, so we've got our ratio of volumes. So if solid B is 405 centimeters cubed, then we have to scale that down to by a ratio of 8 to 27. So we're scaling it down. So the volume of solid A is going to be 8/27ths of the volume of solid B. So volume A is 8/27 times volume B. Which is equal to 405 centimeters cubed divided by 27 times 8. And that is a real challenge to do in our heads, because this is not a calculator paper. So what we need to do, if we get a really difficult fraction like this, the best thing is to try and divide this into prime factors. So we know 405 will divide by 5 because it ends in a 5. 5 goes into 48 times, and 5 will go into 5 once, so that's 81. And 81 is 9 times 9, and 9 is 3 times 3. So this is 3 times 3 times 3 times 3 times 5. So this is 3 to the power 4 times 5 divided by, and 27 is just 3 cubed because we cubed the 3 to get 27, and all that's got to be times by 8, which is 2 cubed. Well, the 2's can't cancel into anything, but the 3's will cancel. That's 3 cubed will cancel with the 3 to the power 4 to leave just 3. So then we've got 3 times 5 times 2 cubed. Well, 3 times 5 is 15. 15 times 2 is 30. 30 times 2 is 60. And 60 times 2 is 120, which is what we were hoping it would come out to. So I think we've shown that the volume of solid A is indeed 120 centimeters cubed. Okay, I hope that was helpful, and I'll see you in the next video.